Hello, Physics 106 class. My name is Caelan Mark, and I'm going to be talking about induced current and Faraday's law in this little mini lecture. And my overall goal is that I explain these concepts and equations to you well enough that you as, college students can go out and explain the problem to someone else or figure out the problems or equations just using some algebra. As you go through this lecture, I want you to be thinking about how this concept of induced current might be used to produce an application such as generators, which I have a picture of in front of you. And right now I'm just going to very briefly show you Faraday's law, but I do want you to notice one of the symbols, the delta phi, in the upper right corner of the equation. And right now, I just have a picture of some magnetic fields. I don't want you to focus on the fields so much as just to kind of, get them in your mind about and the things you've learned about them. Okay, so jumping into it, the phi, as I mentioned earlier, is the symbol for magnetic flux. And specifically the magnetic flux that we're going to be looking at is going to result from either a change in the magnetic field strength, symbolized by the B, or the cross-sectional area, symbolized by the A, or in the direction that the magnetic field affects the cross-section A, symbolized by the cosine theta. So remember just basically that in order to result in a magnetic flux, or in the strongest magnetic flux that you can possibly have, your magnetic field needs to be perpendicular to your cross-sectional area. And the only time your cosine theta component will come into play is when those two are not directly perpendicular to each other. So if you look at the image on the right side of the screen, the theta is the difference between your magnetic field being directly perpendicular and how much it is offset by. Okay, and that is our magnetic flux. So back to Faraday's law, which is symbolized by the epsilon, the fancy Greek E. Okay, all that is saying is that anytime we have a change in our magnetic flux given by the delta phi, we can also find the induced current, or epsilon E, when we figure out that component along with the change over time, the delta T, and the number of coils that we have in our system, or that is going to be, carrying that induced current given by N. And we could leave it at that and we would have our equation. We would be able to find out the value of the induced current. But as you can see, there's also a negative N, and that comes into play when we talk about the direction of the induced current. So this is one of the examples taken from our textbooks where you have a magnet and some wires. Well, as we move that magnet closer to the left side of the screen, we will be inducing a current to the right side. The negative indicates that it is simply just going to be the opposite direction of however our magnetic flux results. So because we're increasing the magnetic field strength to the right, hence we're getting a magnetic flux to the right, we result in a current that is going to be traveling to the left. Okay, so now back to the original problem I introduced. How can we use this to develop generators? In these pictures, I show several ways that we can produce some electrical energy, but all of them use the same concept. Whether it is, coal, hydroelectric, wind, Or in the bottom right corner, it's using solar power to heat up and mirrors to heat up a tank in the middle. Um, so very quickly, the way generators work is that they have a coiled wire um, that just essentially wraps and loops around a magnet that is going to be spinning, okay? And anytime we get some spin, whether it's from, the water in a hydroelectric dam just coming down from because of gravity, or the water in like a in a coal power plant that is being heated up and then used to turn these generators, we're going to be resulting in an induced current, and that is what the electricity that is generated is it is an induced current given by us in changing the magnetic field, so in relationship to the individual wires and magnets that are inside this generator, and that is how we apply this concept to produce something like electricity. Thank you, everyone.